Hi folks, this is question 7. We're just given a table here. So during an experiment, the number of bacteria in a dish can be modelled by this function. So T is the time in hours here. So if I want to know how many bacteria are in it after 1 hour, I'm just going to put a 1 in instead of T, and that'll tell me. And then if I want to know how many after 2 hours, after 3 hours, after 4 hours, and so on. And that's what's in the table down here. That's what it means. So what we're going to do is we're just going to keep putting in the values. You can do it on the calculator with the table if you want, but if I put a 0 in instead of T everywhere, so if I just do 0 cubed minus 6 times 0 squared 6 times 0 plus 20, you might be able to see already that that's going to be 20, but if you put it on the calculator as well, it'll give you 20, and I'm only doing that just to show you what to do. But we do exactly the same thing then, but we put a 1 in next time, and when you put a 1 in, you get 21. So that's when you put 1 in everywhere instead of x. Then 2 is already done for us, so we don't need to put in a 2. You can check it if you want. Then we put in a 3 everywhere and we get 11. Then 4 is done for you as well, it's 12. And then we put in a 5 and we should get 25. That's our table filled in. The next part, we're just going to put that onto the graph. So 20 would be here. 121 is in here. 216 is here. Then 311 is in there. 412 is here. And 525 is it's up here. Right, you're just going to draw a graph then as neat as possible. So just be careful with it. It's going to be something like that. I was probably a bit too flat there at the bottom. Right, next bit. So find p dash t. So we're just finding the derivative then of that function. So p dash t would be, so there's an automatic 1 there. So we do the power times the number in front. 3 times 1 is 3, t to the power of 2, minus 2 times 6 is 12, t to the power of 1, or just t, plus 6. And that's all. Now find the value of p dash 2. That's just going to be where I put a 2 in everywhere instead of t into the function, into what I've just done, into the differential of it. So 3 multiplied by 2 squared minus 12 times 2 plus 6. That would give me 12 minus 24. Now you could go straight to the calculator there on the top line. It's probably the easiest thing. Plus 6. So we get minus 6. I'll explain what this means in terms of bacteria. So p-4 is equal to 6. So that means that the slope at the point 4 would be equal to, positive 6, was it? Yeah. So at the point 4 then, that just means that that slope there, so the tangent that's at 4 is 6. It doesn't look like 6 there. Could be something to do with the way I drew it. So yeah, our tangent goes up like that at 4. So that means after 4 minutes, the rate of the bacteria growing is 4. So after 4, sorry, I think it's hours. Yeah, T is in hours. After 4 hours, the rate of bacteria growing is 4. So at that stage, they're growing by 4 times the amount. Right, the number of bacteria in a different experiment can be modeled by this, where K of T is the number of bacteria and T is the time in hours since the start of the experiment. So very similar, it's just a different function now. There are 3,000 bacteria at the beginning of the experiment. Use K of T to find the number of bacteria after 1 hour and after 2 hours. So after 1 hour, that's K of 1. We're just going to put, so it's 3,000 multiplied by 2.72 to the power of 0.5 times 1. And we just put that into the calculator. And that's going to be 4947.7. Then we do the same over here. So K of 2 is equal to 3,000 multiplied by 2.72 to the power of 0.05 times 2. We're just putting a 2 in where the T is. And straight to the calculator again. And that gives me 8160. Then after n hours, there are at least 3,500 bacteria according to K of T, where n is an element of the natural numbers. By continuing the pattern above, or otherwise find the smallest possible value of n. Right, easiest way of doing this is, so that was where I put a 1 in instead of n. That was where I put 1 in, like we've just done, or sorry, instead of T. This is where I put a 2 in. If I just keep going, if I just put a 3 in instead of T into that, what I've just done, I'm getting 1, 3, 4, 5, 7, and I'm rounding that off. Then if I put a 4 in, I'm getting 22, 195. So I'm trying to get the one that's just above 35,000. So we haven't got there yet. So that I put in a 4 that time. So now I'm putting in a 5. And that gives me 36,605. And I'm rounding that off as well, but it doesn't matter. So that was when I put a 3 in, that's when I put a 4 in, and that's when I put a 5 in. So it's 5 is the answer. So the smallest value of n would be 5. So that's when I'm putting it in instead of the T in that thing there, like I did in the last part. And then that's all we have to do for that question.